Welcome to this presentation. I'm Vincentius Timothy, and I'll present a paper titled Data Preparation Step for Automated Diagnosis based on HRV Analysis and Machine Learning. The authors of this paper are myself, Aristijadi Prihatmanto, and Kyung-Yeon Ri. This presentation is brought to you by Institut Teknologi Bandung and Pukyong National University. This presentation is divided into background and objective, overall proposed method, theory, implementation and discussion, and conclusion. We all know that the characteristics of our heart can be measured using electrocardiogram or ECG. Typically, the ECG signal will look like this. But do you know that from ECG signal we can actually diagnose diseases? That's right! There has been various publications about this, but the most prominent ones are the diagnosis of sudden cardiac death, acute myocardial infarction, diabetic neuropathy, and other heart-related diseases, even psychological symptoms such as stress. This automated diagnosis, if done properly, enables preventive measures to be applied beforehand, and subsequently, this diagnosis will be able to save both time and money. Therefore, the aim of this paper is to propose a method for automated diagnosis. The proposed method comprises of 3 steps: dataset preparation step, machine learning step, and disease classification step. Specifically, this paper describes the dataset preparation step of the proposed method. Now, the dataset preparation step aims to prepare the dataset for machine learning step and for disease classification step. The machine learning step aims to obtain the classifier model and its performance metrics. Finally, the disease classification step aims to perform automated diagnosis. The input of the dataset preparation step is ECG signals, and the output is dataset for learning or classification. However, what kind of dataset meets the requirements for learning or classifications? It is the heart rate variability or HRV parameter dataset. As the name suggests, HRV parameters describe the variability between consecutive heartbeats. HRV parameters are obtained from HRV analysis, which comprises of time domain analysis, which creates time domain parameters, frequency domain analysis, which creates frequency domain parameters, and nonlinear analysis, which creates nonlinear parameters. Together, the 3 of them creates HRV dataset. But how to process ECG signals to become an HRV dataset? Enter the algorithm for dataset preparation step. The algorithm is this. The input signal of HRV analysis is not ECG signal. Instead, it is air-to-air interval or RRI signal. Simply put, RRI signal is the time variation between consecutive heartbeats. Therefore, firstly, we convert ECG signal to RRI signal. The result is raw RRI signal, which contains noises called ectopic beats. Ectopic beats are abnormal beats caused by unusual impulses, which create ambiguity in the RRI signal. Therefore, secondly, we detect and correct ectopic beats. Besides that, frequency domain analysis requires the signal to be stationary and uniformly sampled. To create stationary signal, we detrain the RRI signal. To create uniformly sampled signal, we resample the RRI signal. Finally, the RRI signal meets the requirements to undergo HRV analysis. The resulting HRV parameters are only for one ECG signal. To create a good dataset for learning, we need many HRV parameters like this. Therefore, the processes above is iterated for each input signal, and finally, those results are concatenated. This ends the dataset preparation step. 2 ECG signals are used in the implementation of this step. One is clean ECG signal, while the other is noisy ECG signal. The result for the clean ECG signal is this, while the result for the noisy ECG signal is this. These 2 results show that its procedure works as intended, even for noisy ECG signal. Furthermore, the resulting HRV parameters for both signals are this. This table shows that HRV analysis is successful in generating time domain, frequency domain, and nonlinear HRV parameters. In conclusion, its procedure works as intended, and the HRV analysis is successful in generating time domain, frequency domain, and nonlinear HRV parameters, even for noisy ECG signal. Thank you for watching.